Hello everyone, this is Dan, and we are beginning our function transformation series with linear functions. So we're going to go over some basics first, and then we'll get straight into it. So if you remember, our linear functions are typically in the form of y equals mx plus b. But for this, we're going to be using a baseline function of just y equals x, as you can see graphed below. Now, m is our slope. So when m is greater than 0, our graph is going to increase from the left to the right. In other words, it's going to slope upwards. And when m is less than 0, it's going to slope downwards, or rather it's going to increase from the right to the left. Now, when m is 0, the graph is going to be a horizontal line, and when m is undefined, the graph is going to be a vertical line. So if we take a look at these graphically, you can see that when m is greater than 0, your graph slopes upwards and to the right. And when m is less than 0, the graph slopes downwards and to the right. And when it's 0, our graph is a horizontal line. And when m is undefined, our graph is a vertical line. Now, our y-intercept is going to determine where the graph is vertically. So it's going to move the graph either up or down, depending on whether our y-intercept is positive or negative. So if our y-intercept is positive, it'll move our graph upward by b units. And if our y-intercept is negative, it's going to move our graph downwards by b units. So if we take a look at some examples, we have our baseline function on the left of y equals x. And then on the right, we can see that our b is positive. So this is going to be moving upwards by 2 units. And that is exactly what just happened. So what happens when we have it negative? So if our b is negative, it tells us that we need to move down by that many units. So as you can see, our graph moved downwards by 3 units, which is exactly what we said it would. Now the x-intercept determines when your graph intersects the x-axis. So here, we're going to get into a little bit of a different looking formula, but what you'll see is that when it's positive, our graph is going to be moving to the left by b over m units, and when it's negative, our graph is going to be moving to the right by b over m units. So if we take a look at our original function, y equals mx plus b, we need to turn it into something so that it is solved for x. And in order to do that, what we do is we start with our original function, y equals mx plus b. We are solving for x, so we need to subtract b from both sides. We get y minus b equals mx. And then we divide by our m. So here we have x equals y minus b over m. But our fraction rules tells us that when you're dividing both things on the numerator, or everything on the numerator, by the same denominator, you can just separate them out. And so our x-intercept is this negative b over m. And so this will tell us how our graph shifts left or right. So just to recap, m determines our slope, our orientation, and how steep our graph is. Our y-intercept, or b, tells us if we're moving up or down. Our x-intercept of negative b over m moves us either to the left or to the right. But you have to remember that your y-intercept and your x-intercept are kind of related. So just be a little careful there. So let's do a sample question together. We want to transform y equals 3x plus 2 to move 5 spaces upwards. So the thing that moves us vertically was our y-intercept. So if we want to move upwards, we need to move with a positive 5 spaces. So we're going to have y equals 3x plus 2, and we're going to add 5 to this because plus 5 moves us upwards. So we're going to have y equals 3x plus 7, and that's going to be our answer for this. See, kind of simple. Let's do another question. We want to transform y equals negative 2x, so it points up and to the right, but with the same steepness. So currently, y equals negative 2x points down, kind of, well, it's supposed to intersect in the origin, but you know what I mean. But it is sloping downwards. So we want it to slope upwards. So the only way to do that is to turn our -2, which is our m, into a +2. And remember, we want it the same steepness, so it's going to have the same magnitude. So the 2 is going to remain the same. So for this, we just have y equals 2x. And now, if you graph it, it'll point upwards with that same steepness. Let's do one last question together. We want to transform y equals 4x minus 2 so that it moves horizontally 2 spaces to the left. So the first thing we want to do is what we did before. We want to transform it so that it is in the form x equals. So we have y equals 4x minus 2. So we're going to add 2 to both sides. And we'll get y plus 2 equals 4x. Now to solve for x, we need to divide by 4 on both sides. So now we have x equals y plus 2 over 4, which is the same thing as saying y over 4 plus, and here we'll have 2 over 4. But from our fractions, we know that 2 and 4 can be simplified to 1/2. Now, we are looking at our instructions to move this 2 spaces to the left. So if we're moving it to the left, we need to subtract. So we have x equals y over 4 plus 1/2 minus, and here we're going to subtract 2. So now we need to convert this into our fractions and see where we go from there. So we have x equals y over 4 plus 1/2 minus 4 over 2. So 1/2 minus 4 over 2 is the same thing as saying x equals y over 4 minus 3 over 2. So now all we need to do is turn this into our y equals formula. So we'll add the 3 over 2 to the other side, or to both sides. So we have y over 4 equals x plus 3 over 2. And now we can multiply everything by 4 to get rid of that denominator. So we have y equals 4x, and now 4 times 3 over 2. Remember, you can multiply your numerators, so 4 times 3 is 12, but then we're dividing by 2, so we get plus 6. And this is how you can move our y equals 4x minus 2 spaces horizontally to the left. Okay? I hope you guys had fun in this video, and if you have any questions, don't hesitate to ask us in the live lessons or use the Ask a Tutor feature. I will talk to you guys next time. Bye!